In this experiment, we created a saltwater battery and used zinc and copper as our anode and cathode respectively. At the zinc strip, the zinc ions combine with 4 hydroxide ions to form 1 ion of zincate, leaving 2 electrons behind on the zinc strip. The chlorine ions from the salt as well as the water molecules react to form hydrochloric acid and hydroxide ions. Over on the copper wire, 4 electrons which came from the zinc strip combine with oxygen dissolved in the water and 2 molecules of water to form 4 hydroxide ions. The sodium ions from the salt combine with these hydroxide ions to produce sodium hydroxide. The hydrochloric acid and the sodium hydroxide then combine back into salt, so the salt is merely in the picture as a way to move charges through the water, and it's not used up. In short, when the nail and copper wire are connected via an electrolyte, a reaction occurs and causes electrons to move from the nail to the copper wire. And moving electrons is the very definition of electricity, so we just showed that we can generate electricity through chemical means. In this experiment, we created a simple lemon battery using zinc and copper as our anode and cathode respectively. At the galvanized nail, 3 zinc atoms separate into 3 zinc ions and 6 electrons. The zinc ions then combine with the citric acid found in the lemon to form zinc citrate and hydrogen ions. The hydrogen ions will then travel through the electrolyte over to the copper wire. And at the copper wire, the hydrogen ions combine with electrons which flowed from the nail through the circuit to the copper wire to form hydrogen gas. In summary, we observe that electricity has been generated by the lemon battery due to electrons moving from the nail to the copper wire during the reaction.